This example comes out of section 8.3, Laws of Logarithms. This question gives us an instruction we haven't run into before. It says write each expression in terms of individual logarithms of x, y, and z. So what they're asking us to do is basically pull apart this big fat log into a bunch of smaller logs. If we use the laws that we just went through, we could write this as log of x to the fifth minus the log of y cubed plus log of square root of z. And notice those are in brackets because they were both in the denominator. If I keep going with my laws of logs, I can say, well, this one is 5 times the log of x, because that exponent can come out front, minus 3 log of y, minus, now root z is the same as z to the 1/2, so 1/2 log of z. And now we have what they've asked us to do, which is we've written the expression in terms of individual logs of x, y, and z. So in this one we've got log base 4 of y squared times z divided by the fifth root of x squared. If I follow through the same type of steps, I'm going to say, well, this is log base 4 this time, notice, of y squared plus log base 4 of z minus log base 4 of x to the 2 over 5. Fifth root of x squared is the same thing as x to the 2 over 5. The minus because it was being divided. Now I can bring each of these exponents out front of their logs to say this is 2 times log base 4 of y plus log base 4 of z minus 2/5 log base 4 of x, and we've written it in terms of individual logs of x, y, and z, and so we're done that one. The last one, in a way, is simpler than the first two in that there's only a single x to the fifth term inside the brackets here. I just wanted to show you that you could go about this one in two different ways and still get the right answer. You could say that this is log base 6 of x to the -5, which is then going to be -5 log base 6 of x, and that would be correct interpretation of your rules. Or you could have said, oh, well, this is log base 6 of 1 minus log base 6 of x to the fifth, which is totally true. Log base 6 of 1 is 0. Then I'd have 0 minus log base 6 of x to the fifth, which is -5 log base 6 of x. Same answer we got up above, just approaching it in a slightly different way.